Okay, so as I promised on last Friday, this video or this next lecture will be mainly focused on how to use MATLAB Simulink to create some simulation results, and also try to show you how to write a MATLAB program to draw root locus. Okay, so the first thing you want to try for this Simulink is that you can start MATLAB like on Mac or on the PC. You start MATLAB and on the command window, you type Simulink, just like what I did here. So you just once you start here, and you will see the pop up a window showing Simulink at the very right over here. So typically when you start everything, unless you haven't started anything yet, so you want to go to Simulink and click this arrow. If you see here the arrow, and you click here, then you will be able to see some options, right? So so first, once you get to this screen, and a lot of time it takes some take a few minutes to pop up the screen for the first time you load the Simulink. So because I loaded Simulink before, that's why it could pop up very quickly. So you just like when you write any MATLAB script, you want to start some kind of fresh project. So here you see on the top here there's called a new model. You click this down arrow. You select new model, and then you put some window here, right? So this is something you like a platform you are trying to work with to generate this simulation results. So the very if you scroll down this kind of check this kind of things, you will find out they have different different kind of options, have constant and have data type conversion, all those kind of things. Has a lot of options. And in this class we mainly use continuous function. So for example, you do derivative, you do integration, you do and then you do PID control, all these kind of things. Then one of the things called transfer function. So remember when we study the transfer function, right? Transfer function give you the option actually to write anything, just like our controller, you can represent into transfer function, or our system you can represent as a transfer function as well. So this is a very very wide, intensely used, I would say. So you pretty much can build everything on top of the transfer function as we already studied. So you want to make sure when you start something, you go to check. If you do not remember, just go down to check and say common use blocks and a continuous function, discontinuity, all those kind of things. And then there is something called a math operation. So so if you see here, they do absolute value, they do addition, and all sort of things, have some gain over there, and can do some function as well. So you can go down to see what they have here, and then you go down again. There is something called sinks. So the sinks basically is something like a display. So you have scope that's very widely used for Simulink. The scope more or less like you have a signal and you want to display, and then this is more or less like something on this oscilloscope, right? Oscilloscope, you see one D signal, you have input, output. So this is one way to see the signal, and the other one is called something called XY graph. So just like when you plot this XY plane, you can also plot X as time, for example, Y as our magnitude. But at the same time, if you have two signals, you have one, x1, and the other one is x2. You want to plot this as grid, say x-axis is x1, y-axis is y2. You can also do the scope. And the third thing is, typically what we do is remember when we try to study the signal, we want to typically we want to have some input and output. Here some has different kind of functions. Has chirp signal, has constant, and also give you if you go down, you'll see there is a pulse generator, generate different pulses and repeating sequence, and then it has sinusoidal wave and have step input. So as you know, for this particular class, we mainly use a sinusoidal wave and a step input, step signal. So this is some, and you can check the other kind of blocks as well. So let's start with something very very simple to see whether how can we build something that you can actually see, right? So visualize the results. What we want to start something today is you first of all we want to get a transfer function right there. So let's say you click this one, you drag over here, you get a transfer function. Okay, this is the basic one what they generated for us. So I want to start with this one, then we'll show how actually we can change this based on this default one. Okay, so then we say we want to display a signal, right? We want to the first thing of course we want a source. So the source is, let's say we do step function because we want to monitor the transition response. So you can click the line. This basically the step input will get into our transfer function. Okay, so that means this means the step is our input source. Then we get a transfer function. Then we want to get output. Okay, from here we want to visualize what the signal look like, right? You want to go to sync. Say I go to sync. I want to use like oscilloscope. This is just a 1D signal time in our x-axis. Then you connect these two things. You see, when you drag the line, it automatically connects this all this kind of stuff. So I want to make it looks nicer. So you can also do that. And let me see, I can make it bigger actually. So let's to make it easier. Yeah, this sometimes it didn't work that well. So anyway, so now you get this very simple stuff. As you can see from here, this is more or less like our first order system, right? If you remember, this is the first order system has static sensitivity gain or static gain is 1, and we have this time constant 1 because tau s plus 1 is our first order system, and we want to see if I have step input, then I have this output. Through this transfer function, I will get some this kind of plot, right? Gradually increase and get to steady state. So let's write. You see here has a right arrow called run. So you run it, then it's down. Now you can double click this scope. Okay, you see something like when you double click this scope, you see something like this, right? It's not easy to view. Sometimes this is just a graphic too small to view. You try to expand everything to make it fill the screen. You click this just expand the screen, and from here you can see the signal start from 0 at the very beginning is 0. At time equal 1 second, it get a response. And remember when we if our time constant first order system is 1, so basically from start to continue for 1 second, and this reach about 6.32 63.2 second, 0.632. So this is close to the number we typically see, right? So if you want to see the bigger scale, and you can see make it bigger and bigger. So you can actually from here it's more or less like what we expect to see, right? I have step input and a gradual increase to with static sensitivity to 1. And then I have this output. Okay, let's this is very easy to understand. Let us modify this a little bit to see what we can see. So as you can see here, this is our transfer function. Transfer function we can do a lot of controls. Let's say I want to change the numerator, right? Numerator right now coefficient is 1. I want to make the static sensitivity bigger for you. That's something sometimes we want to see, right? I modify to make it 10. Okay, I click save, then I run it again. I do it. So now of course because static sensitivity is 10, the static value will be 10 here after it's stabilized. If you see here, this right side is 10, and once it stabilized, it indeed reach 10. So let's do another modification. Let's say we want to change our time constant. Okay, let's change our time constant to be it's a tau s, right? We make it 10. Okay, we make it 10. Time constant 10. So it will be now it will take about 10 seconds to actually respond. Same thing. We run it again, and we see the scope. As you see here, it takes much longer to reach the steady state. And here, this is the one common thing you will see. If this scope I only display till about 10 seconds, how can I increase the number of view so that I can visualize the whole thing? So let's do some modification. The default is from 0 to 10 x-axis, y-axis from 0 to 6. I try to visualize the whole thing. So I want to modify this a little bit to see bigger scale or smaller scale. I think, let me see, you go to, okay, then yeah, go to simulation. Then they say model configuration parameters. Go click this. I think it's here. So let me double check. So it says you see the starting time of default will be 0, then stop time will be 10, as what we see over there. Because our time constant is like 10 seconds. I want to visualize much bigger one. Let's say I change it to 20 seconds. Okay, that's one thing you can see. So let's say I do that. I click apply. Okay, then I run it again. As you see here, although this is if you want to click this, you open this window, it's still as the scale as what we observed before. But you try to click this. Now it goes to 20 seconds, right? So 20 seconds look like it's still not enough. And this sometimes we need to go backward forward to adjust our simulation, so that we'll be able to see everything. So let's say I want to change it again. I want to change it to 40 seconds, for example, instead of 10 seconds. I want to change it to 40. I run it again. As you can expect, it takes a while. I hope it will not break. It takes a long time to respond now, to process. Okay, I hope my computer didn't stop working. Let me save this to see what's going on. It looks like it because our simulation time is really long. Probably the run out memory actually for my computer. That's good. Sometimes you see something like this. What are you going to do? So that's hopefully. Let me try to stop my MATLAB. Okay, I'll stop here. Force quit over here. See, MATLAB is not responding because our simulation time is too long. So let's say I will try to start MATLAB again, and to see what we are going to get. Okay, so we probably need to modify another thing again, modify another stuff to make the time step probably shorter, longer, so that they do not have too many data points for us to simulate. So let's say I started with the Simulink again, the same thing. I hope they stop. Yeah, they indeed saved my previous Simulink windows. As you see here, it takes a long, once the next time you start this MATLAB, it takes quite a long time to load the Simulink. Just wait over there. Depending on your computer, it may be faster. If you have good computer, if your computer is worse than mine, it probably will take a lot longer to do that. Okay, now it's pop up, and since here it seems like it's auto saved my project. Let's see whether it's the one I have just now. I don't want to restart everything. Oh, it probably takes longer. Oh, it didn't work. Let's restart. So this way you can be familiarized with how to build things quickly, right? So let's say I'll try to do this. Now I know I need to write my source first. I need my step input, and I need my transfer function, continuous case. I need the transfer function here. I connect this, and then I need my sink. I need my scope. Okay, so I have my scope here, and just now I changed this to be, top to be 10, time constant to be 10, right? So let's see, I want to modify this simulation model configurations. So now it says start time, stop time is still 10 seconds. I want to change it to 40. Okay. So maximum step size, minimum step size. So relative step size. Let's say I want to make it the step size bigger. So let's say minimum step size. Let's say I want to change it to 0.1. Initial step size. Let's say 0.1. To see whether it can do things better, right? And do things quicker. So variable step and okay. So let's see what's going to happen after this. Number conservative zero crossing. Okay. I run it again to see whether it will stop my computer. Okay, now it's quickly done it. So I do the scope, do this visualization. Now it's closer, right? Closer to what we want. So let's say I increase my scope time again. So say I instead of 40, I will make it 100. Okay. So then I run it again. I do it second time. Now you see now I see I have my time constant at 10. I change step size to be bigger. Now I got this this system responds faster. So sometimes you need to change that settings to make the simulation runs reasonably quick. Otherwise it takes forever to run. Just like what we experienced just now. Okay, so this is something we tried, and let's see we try something. This is the first order system. The second thing we want to try is like second order system. Let's say I want to change this static sensitivity to be 1 again. I want to change my second order system has let's say I have this system have omega n. Let's say it's 1, and I have damping ratio. It's damping ratio. Let's say 0.5. So 0.5 2 times 0.5 times 1. I will have 1. The last one is 1. Let's say this simple second order system, right? So the second order system, let's say I run it to see what I get. Okay, so visualize this curve. As you see here now, you see some addition artifact because we changed the step size. Now you see the second order effect, right? So I have this starting from 0 and gradual increase and have jumps. The one thing you probably kind of see now, this actually the curve is not smooth anymore. And the reason behind it is we changed our simulation model configurations. So you want to change this to be, I want to use my smaller step size, let's say 0.01, and this again I do 0.01. The time instead of 100 seconds, let's say I change it to 10 seconds, just like to the default number. So sometimes you need to play with these numbers to get a good curve. So let's say we try it again. Oh. Seems like it take another loop to do this. Huh. That's weird. I should not make that small steps. So I have to stop it again because it will take a long time to. Let's wait a little bit to see what's going on, where they can actually get things done. Okay, seems like it's not. So let's restart. I have to first quit my MATLAB. As you see, sometimes it's frustrating at the very beginning. It's freezing, then just like what we experienced just now. So this could happen to you when you start building your MATLAB Simulink. So for this kind of case, for what we changed just now, we made our Simulink step size too small, right? So you want to make it bigger, or you want to make the simulation overall time much shorter. So let's say I start a Simulink again, and we can try something out. So it takes some time to get everything started. because it's a larger package, that's why it take quite a bit of time to load Simulink. Okay, so again, looks seem like starting from here is easier. So I just start from here. Once you do this kind of thing quite a few times, you will be very familiar with where things are and how to build things quickly using Simulink. Okay, so let's say I have this, I have a continuous signal, I have my transfer function. I just link these three, link this one, and now I say I have 1, 1, 1, right? All these are ones. Okay, so apply. Let's say I'll modify my model configuration parameters to see what the default. So it has default from 0 to 10. Everything is auto. Let's run it and to see what we are going to see from this default. Okay, so now we see this. Double click. Yeah, this looks reasonable for default settings. You see here it's pretty smooth and everything is pretty smooth. That's what we get used to see. Let's say if I want to modify the system a little bit and I want to make it like from this instead of 0. Let's say I want to make it 10. Okay, I make the top 10 omega n squared equal 10 to see what we see. This is like the transfer function of second order system, and I run it. I get the result again, right? So as you see here, result again is not smooth, and you want to change this Simulink settings, and hope this time it will not freeze. I want to, let's see what time I want to see, like 5 seconds. Okay, 5 seconds, and I say the initial step size. Let's say I want to change it to 0.05. See whether it will freeze again. So sometimes it freezes if you have too small steps, because it takes really long to finish everything. Look like it's getting done, and now it's smoother, right? So if you see here, it's smoother, and you need to play with it a lot of times to make sure you get things close to what you want. And as you see here, it has second order effect, and of course you can on top of this you can build something more interesting. Let's say I have 10 on top. I'm changing my transfer function a little bit. If my transfer function like this, it's unlike the regular first order system, and it has derivative effect. And I run it. I see the scope. I get something like this. Okay. Remember what we saw before? This is like derivative, right? 10s. This is like derivative, and because it's a positive number, and it can go overshoot and go to lower shoot. Remember we did this did a simulation for one of the system. We started with something. This is a zero effect. We have negative 0, and this negative 0 has some have this kind of a derivative effect. So that's something you see. So now you get, as you can see here, except playing with this kind of Simulink model configuration parameters, and everything else is very straightforward. If you want to make the curve very nice, you want to play with the numbers, and otherwise you can do things pretty easily. So let's this is the straightforward give you transfer function, and I build the block, get everything done. Let's say I want to do something fancier. What I mean fancier is I try to build something more complex to see whether we can do something, right? So let's say if I do not have my complete transfer function here, let's say I have one thing here, okay? So I have another one transfer function here. This just makes things more interesting, okay? So as you know, you can combine those kind of transfer functions together, but in this kind of for Simulink, you don't have to. So let's say I have, instead of here I have s plus 1, I have s plus 10, for example. Okay, so then I have this system set up. I have my input, and instead of first order system, let's say I make it a motion interesting. I have my second order system instead of first order system. Okay, so if you do not want to do all these kind of things by yourself, and you want to modify this kind of stuff, what do you want to do? Just put a Simulink and see what the signal will look like. So I run it. I see the scope, and realize this. Yeah, this is something like this, right? This third order system instead of second order system, but we didn't see this overall like second order effect. Let's see we try to modify our Simulink parameters. Let's say instead from 1, so from 5 we go to 10. Let's say I make this 0.1. I just want to see how things look like first. So I write. Okay, I scope it. Now you see this overshoot things. Okay, so now you can see, I do not have, that's one step further. We say we do not know the system response, system transfer function overall, but we can still do it for this using this kind of Simulink. So let's say I want to do something even fancier. Remember we have a feedback control, right? We have our feedback system. Okay, so I want to build the feedback system. Okay, I have my feedback system. Let's say now I need some feedback control over there. What I can do is here has math operations. As you see here, it has plus plus. Okay, so from here it has subtraction. What I want is the feedback control need a subtraction, right? So as you already know that from what we discussed before. So here I have this. I put this connect this in together, and remember what we see here. This just didn't work very well. Okay, so let's see. I make it bigger to make it easier to see. See, this is very annoying to me, at least. Okay, so I want to build some feedback control, and let's say this is my system. I want to see from here, right? Just get some feedback, and if you see here, drag the line from here, then you do here. You try to go up. If you try to pick some signal from here, you don't automatically pick it up. But what I find out, if you try to start from something from here, you actually cannot start the line. So you want to start something that connects, just like what I did here. You select from here, and then I go to this direction. You try to draw some lines, and I go backward, go top. Then I can pick up signal. So the lines you can drag left or right to make this looks nicer, or whatever you want to do to make yourself feel comfortable. So this is more or less like this part is our transfer function. This part is our controller, right? Let's say we have controller. You can change this caption here. Let's say this is my system or plant, and this is feedback control system. So this is just like a unit feedback control system. So let's write it to see what we get. Okay, so you get something like this. This feedback control system is a little bit more complex than what we see before. So we want to make something similar to what we did before. Instead of s squared plus plus s standard second order system, we make this system unstable. Okay, we make this 0. And from here you see the plant actually itself is not stable because we have zeros. We have the pole at the imaginary axis, right, at the origin. So we apply this controller. As you remember, if we do this kind of proportional controller, I just do proportional controller here, and I will be able to make the system stable. So the system stable means I can reach a steady state. Okay, so yeah, that's something you can see. So if I want to see 2 signals instead of 1, okay, let's say I delete this. I go to something called I think math operations. I get where is it? Product. Oh, not math operation. This is called signal attribute. I have let's see, where is it? Oh, signal routing. Okay, signal routing. We have a bus creator. I think this bus creator. Instead of I just visualize myself visualize our signal, we want to visualize 2 signals, right? So we want to visualize this. At the same time, I want to visualize the other one. So my input, for example. Okay, not just that, I want to visualize my step input, and with one single scope, I can be just like you have two-channel oscilloscope, and you can actually visualize two signals. Let's see what this is the one actually I need for this. Okay, this is a little bit more challenging for us to see. Where is it? Didn't go. So let's see. I have scope. I have my scope here. I want to visualize my signal. Okay, so I run it. I think I will be able to see two signals. As you see here, I saw two signals. The red, this yellow one is my step input. The pink one is our signal. So the signal of the output. As you can see here, this is very, very powerful, right? I can do this two signal on the scope at once. This is Simulink is quite straightforward to do this. And if you see here, here we say this kind of operation. Just I have two signal. If you want to have three, for example, I can put another one. Let's say I have three. I need another. Obviously, I need another. Monitor another signal, and let's say I monitor here. Okay, I have my three signal instead of two. Let's see what do we get. So you got a three signal. Okay, so I get something like this. And you can monitor this using this one scope to monitor multiple output. So as I try to do over there, right? You can actually try to do 3, 4, 5 by changing the numbers as long as you give source, and you will be able to visualize those kind of signal pretty easily. So as another thing you probably already observe is sometimes the lines could be challenging for you to see. If you want to make it easier for you to visualize, you can actually try to adjust this. One thing I learned over time is if you make these things make it easier for you to visualize, it's easier to actually see what you are doing, right? So you try to make this Simulink graph as straightforward as possible. Sometimes it's not. It's almost impossible to do that, and you can actually make this bigger. For example, here, so I can make this bigger, make all this kind of line straighten out. So I want to make this even bigger. Okay, does it make sense? So basically, what I want to do is I want to make this system as straightforward as possible, and we try to avoid some unnecessary curves or lines across. So what I can also do, for example, is this same thing, right? I can visualize in different channels. So I can, move this arrow. Let's see, I deleted this line. Let's see whether I can delete this. I believe I can delete this line. I can move this one here instead of over there. I try to avoid what I'm trying to do here. I try to avoid some overlapping or crossing, because any signal crossing, will disturb you to see, make your graph more difficult to make mistake, to actually see something you do not want to see. So as you see here, by playing with this thing a little bit, you can make this graph easier and cleaner for you to do and to learn. So I hope this is enough for you to actually do something, right? So the feedback control, as we didn't spend much time to model our actually model out the sensor response. So you can theoretically you can put another transfer function here on the bottom on the feedback loop, and from here you can also do more complicated, model this kind of sensor response. And from this is just Simulink is a very good visualization tool for you to see what's going on actually on the real scenario. So let's start with something like this, and hopefully this is good enough for you actually to start build some Simulink projects for your homework. Okay, so let's go back a little bit. I want to start something on this kind of root locus. So root locus is basically just we do not need the Simulink anymore, and I try to close it because it uses quite a bit of resources. So let's say I go to here, say I want to just like you start from start script, you clear all, close all. Okay, so I want to save my project as let's say lecture example. I don't know which lecture we are doing right now, but let's say I want to say numerator, for example, is 1, denominator equal let's say 1, 1, 1, for example. Okay, I have my system. You use the transfer function, numerator, denominator, and then I have the root locus is basically just root locus, I think, system. Then that will give you the idea how the root locus look like. So for this very simple system, is s divided by 1 divided by s squared plus s plus 1. Okay, so if you see here, this we have 2 poles. One is 2 complex poles, and there are no zero. Everything goes to infinity, and because the 2 poles aligned on the on the same spot horizontally, so this has no real. It cannot cross any real axis. So now you get these 2 lines, these 2 poles, and let's say I want to add something, make it 1 0, right? Instead of two zeros, 2 poles, I add 1 0. I don't want to make it the same point. Let's say I make it a different point. So now I play with it to see what I'm going to get. So as you see here, this is the curve. Actually, I think we did something like this in class. So yeah, this 0.5 by chance is aligned with that again. So let's say I make it to 0.025, the 0. Okay, so you do this, and let's move this 0 here. It's still starting from these two poles, and one go to minus infinity, the other go to 0, end up with 0. So you get this root locus. So we try something. Let's say 1 0. I try 2 0. Okay, then I want to make my third order system on bottom for 1 1, whatever you want to try. So you can write. Okay, you get generate something like this. So we in our class we haven't started with something like as complex as this, but as we'll do something in class next Wednesday. So we'll do something more complex. Hopefully, give you an idea how to sketch this kind of this kind of root locus like this. So yeah, as you can see here, it's very straightforward. Use MATLAB to generate root locus. So in this homework, you are required to do some kind of a root locus sketching of some kind of transfer function. This is something I strongly encourage you before you sketch this kind of root locus, and try to use the MATLAB to verify whether your sketch is right. Okay, so a lot of numbers we don't care, but some numbers as we like the breaking up, breaking in, and crossing this imaginary axis, those kind of points, the critical point we care. You need to make sure you follow that, and also this guideline where it can end up to the infinity. So this part is very simple, unless like Simulink probably haven't done anything yet. But if you try, for this this root locus is pretty straightforward. You basically put a transfer function there in MATLAB, and then you just call root locus line and function. Then you get the root locus plotted on the screen. So that's very straightforward, and I hope that's good enough for this class, and give you a very good start on what what kind of stuff you can work on in this class, in the homework, and also to play with this. Make sure you play with Simulink, play with this root locus on the MATLAB, and you can this is very straightforward, right? If I want to imagine some kind of concept, for example, for this kind of on the book, they give you different scenarios for second order system, third order system. You try to use MATLAB to Simulink to see, what kind of thing they look like, and try to see whether it match with the book plots. Okay, and hopefully that's good enough. And thanks